Well, in the video, I showed this machine, and my question was that why is the motor wheel small and the driving wheel or the wheel that is picking up the water big? Well, before going into this or explaining this, the answer in just one word is force multiplication. Well, let me elaborate. Now, before going into the main topic, I would like to discuss some of the basic concepts that you need here. First of all, what is a machine? In physics, machine always doesn't mean those electrical devices and all, computer machine. No, in physics, machine is not such a thing. In physics, machine is something that can make your work easier. Now, easier in what sense? Easier in three sense. Number one is force multiplication. Number two is speed multiplication. And number three is changing the direction of force. Now, what is actually force multiplication? Well, let me explain all those three by giving examples. That would be better. Suppose you have to move. I am talking about the first point, that is force multiplication. Suppose you have to move a heavy object. Now you have to give a lot of force. Now that's quite inconvenient. So what you will do, you will use an appropriate machine that or on which you will give a less force, but that machine in turn will generate a greater force to move that body or object. And its best example is a crowbar. You have seen crowbar, that by crowbar a man is lifting a heavy stone. So he is applying a less force, but the crowbar is generating a greater amount of force to lift that stone. Now next is speed multiplier. Now from the name you can understand, speed multiplication means with greater speed. That means suppose you have to move something with greater speed or with a high speed, but you yourself will not move any machine part. You are applying force on any of the machine parts. For example, in the crowbar, you are applying force on one end of the crowbar and the stone is lifted by another end of the crowbar. Now, the point at which you apply the force is called the point of effort. So I mean to say that in the case of speed multiplication, the point of load will move with a higher velocity, or you will move the load with a higher velocity, but your point of effort or the point at which you are applying force will not move with that speed. This is mainly used in cases where you don't want to move something with great speed, but you yourself want a great speed as output. For example means the most appropriate example is a cycle. You see, in a cycle, have you ever seen that the velocity with which the back wheel of the cycle rotates, with that velocity you rotate your pedal? Of course not. You rotate your pedal with a much slower speed, but the back wheel of the cycle rotates with a higher velocity, and this is the case of speed multiplication. Now comes a third point, that is changing the direction of force. It is also quite simple. Suppose there is an object and you have to lift it against the force of gravity. So you have to apply a force in the upward direction. Now, can I do something by which I will apply the force in downward direction, or use my weight as the force or use my weight as the force that will lift that object. Of course, the simple example is using a pulley. This pulley will lift the object. I mean, you will pull the rope in downward direction or use your weight to pull the rope, and this force is downward, but this machine will in turn lift the object upward. So this was a simple explanation or a simple concept towards machines. Now the next important concept, rather the most important concept in this topic or the topic that I am discussing, is tangential velocity. Well, now in the video, the two wheels were rotating, or the motor wheel was able to rotate the driving wheel because a band or a rubber band was connected between them, or we can consider a chain also here. Now tell me one thing, that is the length of the band or the chain for which the motor wheel is able to rotate the driving wheel, is its length changing? Of course, it's common sense, and also you can observe very clearly that the length isn't changing here. Now tell me one thing. Suppose I consider a body like this. Now the body is moving with a certain velocity in a direction. Suppose in this direction. Now, if the length of the body or the dimensions of the body are constant, then it means that all the molecules or all the particles or all the molecules, whatever you say, of this body is moving with the same velocity and in the same direction. Rather, leave this direction, just think that they are all moving with the same velocity. Or you can also divide this body into different parts, then all those parts will move with the same velocity, so that the length will remain constant. Now if one part is moving with velocity v and another part is moving with velocity v dash, such that v dash is not equal to v, then the length will change. It's not that much complex, it's a simple concept. Now, in the case of the machine, the length of the band or the chain here was not changing, right? Now, if it is not changing, that means each and every molecule or each and every part of this band or chain is moving with the same velocity. That does mean that the tangential velocity, I mean, if you consider a small part or a small point on this band at the circumference of the small wheel and a small point on the circumference of the bigger wheel, and the length of the band will remain constant, that means the velocity in the direction of rotation should be same in both the cases. Now if it is not same, then of course the length will vary and the machine will not work properly. This was the concept of the tangential velocity. I mean to say that tangential velocity of both the wheels are same. Now these two were some of the main concepts that we need here. Especially the second point, it is the most important concept here, because from here only we can understand what is the purpose of this machine. Well, this was the part 1 of the whole explanation. The part 1 was based on the basic concepts such as what is a machine and what is tangential velocity. Now in part 2 of this explanation, we will use the concept of tangential velocity to understand what is the working of this machine, or for what purpose are we using this machine, whether it is a force multiplier, or it is a speed multiplier, or is it just for changing the direction of the force.